In the last video, we started talking about objects traveling with constant velocity. That is, we said they move equal distances in equal amounts of time. From this relationship, we'll be able to say that the distance an object travels while it's traveling with constant velocity is equal to the velocity of the object times the time that the object was traveling. And in this video, what I'd like to do is show you how we use basic algebra to rearrange this equation to come up with this equation. So let's suppose we're given an object's velocity. Let's say the object's velocity is exactly 2 meters per second. So every single second the object travels a distance of 2 meters. Let's suppose we want to know how far this object travels if we allow it to travel at 2 meters per second for 5 seconds. We're going to look at several different ways to find the distance that this object travels, given first this relationship. To do this, you know that velocity equals distance divided by time. And we're given the object's velocity and we're given the time during which this object's been traveling. And we want to know the distance this object travels. So the first thing that we're going to do is we're going to multiply both sides of this equation by time. And when you do that, what you should see is that this unit of time cancels out with this unit of time. And so when we rewrite the left-hand side of this equation, we get velocity times time equals the right-hand side of the equation, which in this case works out to be the distance. And this is the exact same relationship that distance equals the velocity of an object times the time it's been traveling for an object traveling with constant velocity. That is, for an object moving equal distances in equal amounts of time. So to find the distance that this object travels, we know the object's moving a distance of 2 meters every single second. And we know the time during which this object's been traveling, in this case for 5 seconds. And this is going to equal the distance. One of the things that you should see is that the units of time cancel out. When you multiply a meter per second times a second, you get a unit of length or a unit of distance. And so when you do 2 times 5, you get 10, include the units which are meters, and that's going to equal your distance. Now when you're first learning how to manipulate these, it's often easier to write this relationship velocity equals distance divided by time and immediately insert the values that they know, in this case velocity and time. So let's take a look at how we would do this exact same problem by plugging in the values of the variables to which we know. So for example, we know the velocity. We know the velocity is exactly 2 meters per second. And that's going to equal whatever our distance is, which we do not know yet, and we're going to divide that by the time it takes to travel that distance. In this case, it's going to travel for a time of 5 seconds. Now, the first thing that you should do is recognize that our variable in this case is distance. So we want to solve for the distance this object travels. We want to get this variable all by itself. So the first thing we're going to do is we're going to multiply both sides of this equation by 5 seconds. What you do to one side of an equation, you have to do to the other side of the equation to maintain equality. So what you should see is this unit of 5 seconds cancels out with this unit of 5 seconds. And on the left-hand side, you get 5 seconds times 2 meters per second, and that's going to equal, in this case, our distance. The next step is to cancel out the units. In this case, the unit of second cancels out, and then you get 5 times 2 meters, which will equal 10 meters, and that's going to equal our distance. So two different ways to see the exact same thing. Now what I'd like to do is try one last approach to solving this problem using some very basic algebra. So what I'm going to do is I'm going to ignore the units of measurement, and I'm just going to write that velocity equals distance divided by time. And instead of writing velocity equals 2 meters per second and time equals 5 seconds, I'm just going to rewrite this as a fraction. So I can rewrite the problem as 2 equals distance, which is our unknown, divided by the time, which is 5 seconds, and I've omitted the units. I've left the units out intentionally. Now, what I can do now is I can rewrite this as the fraction 2 over 1. Anything divided by the number 1 is the number itself. So what I'm hoping you see from this variation of the exact same problem is that this is a problem that you've probably seen in a previous algebra class. So sometimes we like to say you cross multiply, in this case both sides. And when you do that, you get 2 times 5 equals the distance, which we do not know yet, times the number 1, which in this case works out to be 2 times 5 is 10, and that's going to equal our unknown, d. And what we should do to completely solve this problem is to write the units of measurement.